Okay, welcome to topic 10.1, which is the last topic of the year, and it's called Circle Basics. First page is just getting to know what circles are, and then the second page we'll get into some theorems. So, do you know what a circle is? Do you? Do you really know? Go ahead and think about what a circle is. Okay, pause the video. Alright, welcome back. Lots of times people know what a circle is, but they can't really define a circle. So here's a couple definitions. Points that are equidistant from a center point. So if I take one point and go out equidistant from that point, and I do that an infinite number of times, I end up with a circle. So that's one way. Or you can say it's an infinitely sided polygon. Getting into some definitions. Radius is a segment with endpoints at the center. So this is circle C right here. We always label the circle with its center point. This is circle C. There's 3 radii. 1, 2, 3. So there's 3 radii in the circle. A chord is a segment with endpoints on the circle. So here's a chord right here. A and B are on the circle. That's a chord. Do you see any other chords? Yes. DE is also a chord. Diameter is a chord, so it has to be a chord first, and it has to go through the center. And is also made of 2 radii. We'll say 2R, 2 radii. So this is a chord. This is a diameter. It's made of 2 radii. A tangent, and I don't mean a gentleman with a tan, and this is different from SOHCAHTOA. Okay, go downstairs. That was one of my better jokes there, the tangent. A line that intersects a circle exactly once comes from the Latin word to kiss. So for example, this is a point on the circle, and this is a tangent line. It just touches the circle once. Whereas a secant line intersects a circle twice. So like this would be a secant line. Alright, so you got a tangent line and a secant line. Is a secant line and a chord related? Yes, well, a chord is part of a secant line. A chord is a segment, and the line is the secant line that goes through the circle. A line that intersects more than twice, that's not possible. Alright? You can only intersect once, you can intersect twice. A common tangent is a line that is tangent to 2 circles. So for example, there's a common tangent right there. There's a common tangent right there. There's another one right here, and there's another one right here. So these 2 circles have 4 common tangents. The point of tangency is just the point where it's tangent. The point where the tangent intersects the circle. Alright, circle relationships to other circles. Circles can be congruent, which means their radii are congruent. So if I have 2 circles with the same radius, they're congruent circles. All circles are similar. Concentric circles, circles with the same center, like this. They have the same center, so they're called concentric. Circles can have 1, 2, or no intersections. So like these 2 circles have no intersections. These 2 circles have no intersections. You can intersect once. You can intersect twice. Alright, so there's your options for that. Inscribed versus circumscribed. We can inscribe a polygon that has each corner has to touch the edge of the circle. That's called inscribed. If If it has a corner that doesn't touch, it's not technically inscribed. And circumscribe, each side, it's on the outside. Each side has to touch the circle. So inscribed is on the inside, each thing touches. Circumscribed is on the outside, and each side touches. Alright, now there's two ways to think about it. In this picture, you could say that the triangle is inscribed, or you could say that the circle is circumscribed. So the triangle's on the inside, circle's on the outside. Over here, we could say that the circle is inscribed. We could say that the triangle is circumscribed. Central angle, an angle in a circle with the vertex in the center. Vertex in the center. Big concept, the sum of the central angles is 360 degrees. So all angles in a circle will always add up 360 degrees. Alright, now this is actually kind of a complicated question here. We have to figure out what that angle is. We've got x's, we've got y's, we've got congruent angles, we've got diameters. There's all sorts of crazy stuff we've got going on in this picture. So solve for the unknown angle. If we can, we want to avoid mixing x's and y's. So like we've got vertical angles here we could use to set up an equation. I don't think we can do it, so let's just go for it. We're going to have a system of equations. So the first thing I notice that these two angles are the same, so I can go ahead and 3x plus 20 is equal to 20y plus 10. That's an equation right there. That's a good equation. Another equation is I could use these vertical angles. I know that vertical angles are going to be congruent, so I could say 40x plus 40 is equal to 20y plus 40. Alright, there's my system of equations. Let's clean it up a little bit. For the top equation, we got 3x. We can subtract the 20y. We can subtract the, actually let's bring this 20, subtract the 20 to get negative 10 here. So I'm just rearranging this top equation here. For the bottom equation, we've got 40x, and we're going to subtract 20y, and we're going to subtract the 40, which makes this 0 on this side. Alright, and we're actually nicely lined up here, and I can subtract these from each other, because negative 20 minus negative 20 is 0. So we're going to subtract, what is 3 minus 40? Negative 37. What is negative 20 minus negative 20? 0. What is negative 10 minus 0? That just doesn't seem right. That's annoying. Oh, it's 30x. Dope. That's supposed to be a 30. 30 minus 40 is negative 10. Quick fix. Alright, and then now we solve that, and so subtract that over x equals 1. And actually we don't need to solve for y. If we plug in 1 right here, you see that 40 times 1 is 40, 40 plus 40 is 80. That makes that an 80, and this looks like a diameter, which makes this 180 because it's half of a circle. So the answer is just 100 right there. Even I make mistakes. The important thing is that you go back and fix your mistakes. Alright, next, an arc. An arc is going around a circle. Maybe not be the whole way around the circle, but a part of the way. A portion of a circle defined by two radii. the measure of an arc is related to the central angle. So up here, if this was a 100-degree angle, then this is a 100-degree arc. 100-degree angle, 100-degree arc. There's two types of arcs. There's a minor arc and a major arc. A minor arc is the shortest arc, connecting two endpoints, and a major arc is the longest arc, connecting two endpoints. A minor arc will always be less than 180 degrees, and the major arc will always be greater than 180 degrees. For example, I could connect this point to this point using this route, or I could go this route. So this blue is the minor arc, and this red is the major arc. Okay, so there's minor and major for every arc. Semicircle is an arc with endpoints that lie on a diameter. Doesn't matter which way you go around, you'll always be 180-degree arc for a semicircle. The arc addition postulate: you can add arcs together. The measure of an arc formed by two adjacent arcs is their sum. So like I can add 80 plus 100 to get 180 up here. You can add them together. Alright, put these arc lines in here. Notice that some of these have 2 letters and some of them have 3 letters. And there's a difference. So arc AB, the measure of arc AB here, starts at A and goes to B. That's a 90-degree arc, because it's a 90-degree angle. What about ADB? Now ADB goes the other direction. Starts at A, it ends at B, but it goes this way. You have to go through D. D has to be a pit stop. So if this was 90, then this is 360 minus 90. What about ABD? So ABD, go in order. If this is the diameter, which it looks like it is, ABD would be 180 degrees. What is measure DC? DC is this, and if this is 90, that makes this also 90, and 60 plus 30 is 90. So it has to be a 90-degree angle. And then the last one is DAC. So now we're going the other direction. So if this was 60, then this has to be 300, because 300 plus 60 is 360. Next, find the measure of each adjacent arc. We do have some diameters we're working with. So obviously that's 90. So this arc here is also 90. These are vertical angles. So this is a 63-degree arc. This would be 63 minus 180, which will put us at 117. And this makes 90 right here, so 63 plus 27. Those are all of the arcs. Just doing a little adding up to 360, adding up to 180 sort of thing. Next, circumference is the distance around a circle. Go all the way around the circle. It's not an arc, it's a circumference all the way around. Perhaps one of the most fun results in the entire universe is that if you take the circumference of any circle, divide it by its diameter, you will always get pi. You take circumference divided by diameter will always be pi. So that's something that you just have to know from geometry class. It's one of the fundamental things. Alright, length of an arc. The length between 2 points, it's a fraction of a circle. It's like a half of a circle. It's like going halfway around or going a quarter of the way around. And here's how you think of that. This is the circumference formula. By the way, if you take this formula over here and you multiply the d over, and then you change the D into 2 radii, you get our circumference formula. We've done this before. We had to do this in chapter 11 to do a little bit, so this is kind of review. So this is arc length. It's a fraction of 2 pi r. It's not all of 360 degrees, it's a part of 360. X is the central angle. So find the circumference of x over here. If we were finding the circumference, use 2 pi r, and the radius is 4, which would be 8 pi. We'll just keep it as, we'll approximate. 8 pi is about 25. Right, find the length of zy. So there's a difference here. This is the length, and this is measure. So different question, but they're using the same arc. So find the length of zy. So the length of zy, we have to use 75 over 360 times 2 pi r. That's x over 360, 2 pi r. I'm using this equation right here, which ends up being, I'm just going to plug that into my calculator now. About 5.2 roughly. And that makes sense because it looks like it's about 1/5 of the way. It looks like 5 of these would get you around the circle. And then it says find the measure. So the measure is just 75 degrees. So a little bit of a difference in these two problems. Length versus measure. Length, you have to use the equation. Measure, you have to just use the angle measure. Alright, we have 2 theorems to discuss, and that's it for today. In a plane, a line is tangent to a circle if and only... So this is now new stuff. Now we're on to some new chapter 10 stuff. In a plane, a line is tangent to a circle if and only if it is perpendicular. Perpendicular. Alright, so if we've got a radius and it is a tangent, here's the then. The then is that has to be a right angle. The radius and the tangent will always make a right angle. You can count on that. So for example, down here in example 4, if we're under the assumption that BC is tangent, then we can go ahead and put a right angle right there. And now we're back to like chapter 9, solving for x. And here's how we would do it. We got to do a squared plus b squared equals c squared. Now c in this case is x plus 6. Alright, let me expand this out. Now the rest is algebra. Hopefully you'll be in algebra next year. You need to remember how to do this stuff. Now remember, when you square x plus 6, you're doing x plus 6 times x plus 6. You have to do the FOIL thing. X times 6 plus another 6x plus 36. Alright, so now we can actually cancel these x squareds off because they're on both sides. So you get 144 is equal to 12x plus 36. From there, subtract the 36 over and divide the 12. And you get 9. X is 9. Then you can always check your work. If that makes that 9, and that would make this whole length 9 plus 6, which would be 15. And that makes a lot of sense. That's 3 times 3, 4 times 3, 5 times 3, 15. That was a 3, 4, 5. That worked out very nicely. Example 5. It's basically the same problem as this, so we're going to skip that. Run out of time. Theorem 10.2. It says if two